Hello everyone. So after defining various examples of groups, we are here to discuss the properties and characterization of groups. Okay, so you have seen the fact that a non-empty set with one binary operation is called a group if it follows that four properties. It is abelian if it also follows commutativity. But we have seen every group should have an identity element. Existence of identity was must for a group. But we have discussed various examples, and one thing can be observed, and you can observe the fact that in every group the identity element was unique. Please go back and see the groups that has been discussed, no matter finite or infinite group. Okay, so now here we are interested to prove the property 1, that in every group Z, identity element is unique. All right. Okay. So to prove it, let Z, and take any binary operation, take multiplication as the binary operation. Let Z with respect to multiplication be a group. Okay, we have to prove that this group has unique identity element. But if possible, suppose that E1 and E2 are two identity elements. Okay, we have taken two identity elements. Then what will happen? Then by definition of identity element, what is going to happen? E1 is equals to E1A is equals to A for all A belongs to G. If E1 is identity, okay, we have taken E1 and E2 as the identity element. So if E1 is the identity element, then E1 is equals to E1A should be A always. All right, so call it 1. And again E2 is equals to E2A is equals to A for all A belongs to Z, because identity element, if identity element is operated on any element of the group, then you are going to get the same element. Means if E2 with A and A with E2 from left or right does not matter, then you are getting A if E2 is identity. Okay, and call it 2. Okay, so from in these two equations, if you will take, so take A is equals to E2 in equation 1, because A into E1 is equals to E1 into A is equals to A for all A belongs to G, and E2 also belongs to the group. Therefore, if you will take A as E2 and we will put in equation number 1, then you will get what? E2 E1 is equals to E1 E2 is equals to what? E2. Alright, we have taken A as E2 in equation number 1 and call it 3. as this is true for all A, and A is equals to E2 also is an element of G. Therefore, this is going to happen. No problem at all. And take A is equals to E1 in equation 2, as E2 is identity. If E2 is identity, therefore A into E2 is equals to E2 into A is equals to A for all A belongs to G. And E2 is what? Identity. And we can take any A. So we can take A as E1 as well, because E1 is also an element of G. Therefore, from here, put A is equals to E1 here. So E1 E2 is equals to E2 E1 is equals to E1, and call it 4. So now, what can you conclude from 3 and 4? There is a final conclusion. There is a crystal clear conclusion here. So from 3 and 4, it is quite clear that E1 is equals to E2. So we were supposed that E1 and E2 be two different identity elements. But when we use the definition of identity element, that if we will operate the identity element with any element of the group, then we will get that element only. So after using the definition, we are seeing what? We are seeing E1 and E2 are the same thing. E1 and E2 are the same element. So this implies identity in G is unique. Alright. So I hope you have enjoyed this property, and this property was so simple, but it is asked in university examinations sometime. Okay. So in the next video lecture, we will meet with the next property of group. Till then, thanks a lot.